write here is I assumed it was going up when I made that prediction, yeah? When I said it was going clockwise, that only works if it's actually going up. So we're going to write assume up, therefore clockwise. Okay, so what's our answer? We're going to get 0 equals 3, rah, minus 200, minus 150, right, and 0. So what's this going to equal? Well, instead this is going to be minus 3 rah equals minus 350, right? And then, do you see how they're minus on both sides? So what we can do is we can just multiply both sides by minus 1, yeah? Which will turn them both into positive. And that means our prediction, positive, therefore our assumption was okay, therefore up. There's going to be times where we're going to get negative answers, and that's just going to mean our assumption was wrong. Yeah? Okay. It's wrong, it's fine. It's fine if the assumption is wrong. Often we're going to deliberately know that our assumption is going to be wrong when we get started, but we're going to do it that way for consistency and for procedure. So if we know that we can buy 3 RAs for $350, how much is each one going to cost? 100 and a bit, yeah? Okay, so I think we'll find 350 divided by 3 equals 116. And because it was positive, because our assumption was okay, we can stick with whatever our assumption was. Okay, so we've done that. That's an important starting point. Now, one thing I want to prove is that now that we've figured this out, what I want to do is I want to prove that if we took moments about C, that it would still equal 0. Yeah? Just to try and give you a deeper understanding of what's going on here. Right? So, if I take moments about C, let's have a look. What are our forces? 0 equals, in this case we're going to say that we know these values. Here's the problem, we can't find unknowns if we measure from C, because if we measured from C, what we'd have is RA times 1 meter, going clockwise or anti-clockwise? Measuring from C, clockwise. And then D would be, this next force would be 0.5. Okay, I'm going to write minus, so 100. Oh, okay. I should write the C itself, right? C itself would be minus 100 brackets 0. I write minus, you don't really get a minus 0, but because the answer is going to be 0, it doesn't matter if it's minus or plus. You don't need to write that. Okay, and then the next one is minus 100 times 0.5. Is it going clockwise or anti-clockwise? Clockwise, so we're going to change it to clockwise. Now it's important to notice that the same force can be clockwise or anti-clockwise depending on the location that we're measuring from. Yeah, if we're taking, in this case, we're taking moments about C, it's going to be a different answer. Okay, and then finally we have RB. And RB is 0.5 plus 1.5, which is 2 meters away. And is it going clockwise or anti-clockwise? From C. Anti-clockwise, so it stays as negative, yeah? We good? You guys are getting all this? You're writing it down? Okay. So what we can then say is 0 equals RA. With algebra, we can just ignore that 1. We can ignore that 0, we don't even write it. Plus 50 minus 2RB. Do you see the problem though? The problem is we now have 2 unknowns and we can't solve that. Right? That's why we have to take, when we measure, we have to measure from one of the 2 reactions. If we don't measure from one of the 2 reactions, we can't solve the problem. Okay. So what we're going to do instead is we're going to use the values that we've already found. We're going to substitute those in. We're going to say 116 times 1 meter minus 0 plus 50 minus 2 times brackets, for consistency I should write that differently. I should write that as 83.3 brackets Pt2. Okay, so now what we have is, if we write this whole thing out, we get 0 equals 116 plus 50 minus 2 times, that's going to be 16. Okay, which we can see is actually the case. 166. And you see that when we compare the forces, they do in fact equal 0.
Mm-hmm.
Now, for homework, what I might say is you could test that, you could do the same thing again, measuring from point D, right? Measuring from point D, and if you measure from point D, you'll find that they still, all the forces will equal 0. If the forces don't equal 0, that means the thing is going to break, right? If it hasn't already, the thing it will break. So we would consider it to be failed, and we need to redesign. If we redesign, we might put in more supports, we might change the materials. If generally what we do is we just make the thing bigger. Okay, so we've found the reactions. Now reactions typically, a question like this, which is pretty simple, finding reactions in a question like this would probably be worth 2 marks in the HSC. There's always, in the history of the HSC, there's always been a question where you have to find reactions. Now, the next part is what we're going to do is we're going to build on this, and what we're going to do is we're going to solve trusses. And to solve trusses, what we're going to do is first we always have to find the reaction anyway, right? But then, okay, we're going to use the simplest truss is a Warren truss. Now, a quick thing that I'm going to start before we're going to have to do a fair bit of trigonometry here. Now, I've talked about this a little bit, but what I'm going to say is, whenever we get given a shape, typically we can assume, if we're not told otherwise, that we can assume that it's equilateral. So the drawings they'll show you will be not necessarily equilateral, but you can assume that the angles are going to be 60-30 triangles, right? Pretty common. So let me just quickly draw over here some information. Well, actually, I'll use this side of the board. Okay, if I have an equilateral triangle, and I make each side 100, what would the angles of that triangle be? What's the angle sum of a triangle?
180.
180 divided by 3 is 60 degrees. Okay. So now what I'm going to do is I'm going to divide this circle in half, right? I'm going to split it in half. What am I left with? Do you see how now what I'm left with is a 30-60 triangle? Yeah? Now, what is this value? Well, I'll show you a very quick way we can prove this. Is if I have the same triangle with 2, what's this side going to be? It's the long side of a 60-30 triangle is always double the shortest side. The side in between, well, we have to use Pythagoras' theorem, but we say 4 squared minus 1 squared equals the square root of 3. Yeah? The square root of 3 is 1.73, but we're using 2, so when you divide by 2, the answer is going to be 86.6%. So this medium side is what I call the disco number long, right? It's 86.6% as long as everything else. Now I'm going to use that a lot because I don't like to stand up here and do trigonometry. I'd rather have you have an intuitive idea of how big it's going to be. So if I tell you that this side here is 1 meter long, well then that means, and that this is 1 meter long, and that this is 1 meter long, all those things are 1 meter long, then what that means is that the height of this shape is going to be the disco number, which is 0.866 triangles tall. Yeah? Okay, so we've established that as our starting point. Okay. In this case here, what do we predict is going to be our reactions? I'm going to label this as A, B, and then I'm going to come back around to C, D, E. That's what I'm going to label it says. What are our reactions? I want you to take a second and I want you to write down on your piece of paper, I want you to draw that shape, and then I want you to predict what you think the reaction at A will be and what the reaction at B will be. Ra and red balloons. What's the prediction? What's this distance? How many triangles? It's half a triangle, yeah? You see it's half a triangle. So it's the same as if I had a beam that just looked like this. I don't know why I drew my triangle like that this time. So it won't be 50. What's the reaction going to be? Who's taking more load, RA or RB? RA. How much more?
All of it.
So are they taking, it's probably going to be some sort of quarter, right? It's 1/4 of the long way along. Is it going to take 1/4 or 3/4?
3/4.
3/4. Okay, so our prediction is that it's going to be 3/4, which is 75, and that side is going to be 25, right? That's our prediction, yeah? But let's prove that. We haven't proven that. So what we're going to do is we're going to say, well, if we find RB, we will know the answer, right? Yeah? So what we're going to do is, how do we find RB? Where do we measure from to find RB? We have two unknowns. What's our other unknown? RB is what we're finding. What's our other unknown? RA. We need to eliminate RA. Where are we going to eliminate RA from? So we're going to, by measuring RA. Right? So what we're going to get is 0 equals RA. Again, I'm going to write this in blue because very few people would even write this. Right? RA times 0. And what's our next force? 100. Okay, so going clockwise or anti-clockwise relative to A. Now, it's important that we imagine this line is going all the way through, and this is its distance. It's perpendicular distance here. So this force, when it's going down, which way is that going? Clockwise or anti-clockwise? Clockwise. Okay, so we're going to change that to a clockwise sign. 100, how far away is it?
0.5.
Yep, 0.5 triangles. And then what's our other force? We only have one other force in this diagram. What's that? RB. Is RB clockwise or anti-clockwise? So I put my finger on RA and I go da 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 da. Which way is it going? Anti-clockwise. So times 2. So what we're getting here is we're going to say 0 equals 50 minus 2 RB. Okay, so I can then bring this side over here. I'm not going to do the algebra anymore. You should be able to see that minus 2 on this side becomes a 2RB on this side. 2RB equals 50. So if I could buy 2 red balloons for $50, how much is each red balloon? 25. My answer was positive. So I made an assumption. I assumed that it was going up, therefore it's going anti-clockwise. My assumption, so it's positive, therefore my assumption was okay, therefore it's up. Again, you don't need to write any of the stuff that's in blue. And so it was 25 kilonewtons up. Then to find RA, or Ra, sum of the forces vertically equals 0. So let's draw that up. We've got 100 down, 100 down, no, we only have 100 downs. 100 down, 25 up. What amount is missing? RA must equal what? 75, yep. So we didn't need to do the moment equation a second time. And the reason we don't need to write the moment equation a second time is because we've already got it here, yeah? We've just used the sum of the forces vertically to figure it out. Are we happy with that? Okay. So we've found our reaction. That's the first part of the question. The next thing we need to do, I'm going to remove this because I think it makes it a little bit hard to read. The next thing I'm going to do is I want you to find the force that is acting. I want us to find the force that is acting. You know what? Pick any two letters on this thing here.
E and C.
E and C. Okay. So this is our member EC, right? Chris Evans, right? I'm going to call him. I remember when Chris Evans was one of the Fantastic Four. Anyway, so Chris Evans is what we're going to find, this guy here, right? That is our target member. And what we want to know is we want to know what force is happening in that member. It can't be a bending force. The whole point of drawing trusses is so that we can avoid bending. Instead, what we're going to do is we're going to, it's going to either be in compression or it's going to be in tension. Okay, so what we need to do is what we're going to do is we're going to draw a line through this object. We're going to draw a line like this. We're going to call that a section line. Now, I don't think either of you have seen Indiana Jones. I'll show you the scene later. But there's a scene right at the start of the very first Indiana Jones movie where he goes to steal this golden idol. Have you ever seen this?
Mm-hmm.
Yeah? He goes to steal the golden idol and he goes to pick it up and he has a bag of sand and he tries to imagine how heavy the idol is. And he takes out a little bit of sand because he thinks his bag might be a bit too heavy. And he swaps the idol for the bag and runs away. Yeah? What we're going to do is we're more adventurous than that. We're going to imagine that we're like Gru, right? And we're going to steal half a bridge. But when we steal half a bridge, you've got to leave the other half in place. You can't just have it collapse. That wouldn't be very, interesting. You wouldn't do well in the superhero, supervillain league, right? You've got to be a really noteworthy crime, you've got to steal half of it and leave it standing. So what we're going to do is we're going to steal this half of the bridge. Right? The more complex side. We don't like the complex side, so we're going to steal the complex side. And like that, it's gone. But in order for it to hold steady, what I need to have is I need to be able to apply some forces. I need to get my minions to push at each of those 3 points at just the right amount to hold it steady. If this minion here pushes or pulls too much, right, the thing will fall over. The minion has to push just the right amount to keep everything steady. Does that make sense? Okay, so in this situation, what we assume is that each of the minions is going to pull their member. Yeah, each of them is going to pull on their section. So I've got CE, I've got the minion I've named Chris Evans because I just think that's funny, and then I have CB. I don't know, Charlie Brown, and then I have this one here, must have been, if you drew it you would know, but it must be D. D-E. Something comes to me, but I don't know, I don't even care about DE. Now, the fact is, at the moment, I don't care about DE, and I don't care about Charlie Brown, right? At the moment, all I care about is my minion Chris. I'm telling Chris exactly how hard Chris needs to push or pull, yeah? At the moment, I've told him to pull. Now, if the minion is pulling on the stick, right, on the piece of steel, is that going to be in tension or compression? Tension, right? So Chris, the minion I've named Chris, is going, I don't know what they say, I've forgotten, but Chris is going to pull on that piece of steel, right? It's going to be in tension. That's our assumption. Now, I might change my mind, right, when I've done my question. Now, the thing is here, okay, so what we've done here is we've used something called the method of sections. The method of sections. There is another way of doing this called the method of joints, right? We're not going to use that method, right? I always try to avoid it. Some of my videos I do talk about it very briefly, but I personally had no trouble using it when I was in high school, right? When I work professionally, I use method of joints all the time because if you need to find every single minion on your truss, every single member, then it's probably faster to use method of joints. But for the HSC, you usually just have to find one, right? Now, what we're going to do here is we're going to find CE. What we've done is we've drawn a section line, we've removed half the truss, and now we're going to find out what is the force that CE, my minion that I've named Chris Evans, that how much that he needs to push or pull to hold keep the thing in place. I don't know how he's standing in the middle of the air. We don't need to worry about that. He's got jetpack, right? Now, here's the thing. Remember we knew the rule that when we have the method of joints, there's two methods here. What we call the lone wolf or the meet-up method. My students came up with these names, right? Maybe I came up with meet-up, but the students have come up with the lone wolf method. What we need to look at is we need to get rid of, right? While I'm talking to Chris is getting distracted all the time, right? He gets distracted by DE and CB, right? So in order to talk to Chris, I need to get the other two to leave him alone for the moment. So I can just talk to Chris, so he'll listen to me, right? So that they don't keep playing paper, scissors, rock or whatever they're doing, right? So what I need to look at is I need to say, how do I get rid of this one and this one? How do I get rid of these two? How do I ignore them? Remember how earlier we had two unknowns and we took moments about one of the unknowns to eliminate it? Well, that would work, but unfortunately there's nowhere where these two meet up. See, they never meet the parallel lines. They're never going to meet. Right? There's that story that, the sad thing about parallel lines is they go their whole lives and they never meet. Whereas concurrent lives, the sad thing is they meet up and then they spend their whole lives growing apart. I don't know which one's sadder, but in this case, these two, they're never ever going to meet. Right? But what we do know is that, so if we use the meetup method, we're going to use moments to solve it. But here, instead we're going to use some of the forces vertically or some of the forces horizontally or some of the forces in the X direction or Y direction is probably the better way of saying that, right? What we're going to look at here is CE is special. CE can do something that the other two can't, right? These two, right, they can only travel horizontally. They have no amount of vertical force. And I have vertical force. I have 25 up. And if something doesn't push down, this whole thing is going to explode, right? It's going to break. So what is the only solution? I've only got 3 minions. What's going to push this thing down to stop that 25 from lifting it up?
25 down.
Yeah, but who? Who can do 25 down? CE, my good old mate Chris Evans, is the only one who can pull this thing down to stop it from exploding, right? So CE is going to need to provide 25 down. But CE is more complicated than that. CE tells me, right, that CE can't just go down. CE has to go diagonally down. And so normally I want to try and pay CE 25 bananas, right? But they're like, no, I've got to go further than 25. How much further do they need to go though? Right? He needs to go 25 down, but what does he need to go total? Well, okay, is it going to be more than 25? Yes. How much more? Like if you had to guess, is it going to be 30? Is it going to be 40? Is it going to be 50? Tell me where you think it's a reasonable amount to stop.
86
Well, okay, so what we know is that this is 86% of that. So if I divide that number by 86.6, I get the number 28.8. So I instead have to pay 28 point something bananas. Yeah? Does that make sense? So what I've just now found is I've now found that Chris is going to be 28. Now the question is it going to be in tension or compression? What did I assume up here?
Tension.
I assume tension. Does my arrow match my assumption?
Yeah.
My arrow matches my assumption, therefore it's going to be 28 in tension. Yeah? So the only working I need to write here is I just need to write sum of the forces vertically equals 0, and I'd say, well, I have 0 equals RB, right, which I've assumed is going up, minus CE, but not all of CE, just the vertical amount. So I'm going to write a little v there, right? So therefore I can say, well, CE equals RB. But what that means is my assumption was correct. My assumption was down, right? I assumed down. So here, my answer is positive. So positive, therefore, my assumption was okay. Therefore, it is in fact going down. Yeah? And if it's going down, therefore it's in tension. Yeah, because we assume tension. Okay. So then, from there, we can say CEV equals 25 newtons down. Therefore, CE equals 25 divided by 0.866 equals 28.87 newtons down. Not down, tension. Yeah? Because we assumed tension. Okay, the next question we're going to look at is we're going to take one of the other two sides. Now I'm going to go with Charlie Brown because I can't think of a good name off the top of my head for DE. So this time DE is the member that we're cutting through. Oh, sorry, CB is the member we're cutting through. Now we're going to pretend that we haven't already found CE. That's what we're going to pretend. It would change things if we knew how to do it otherwise. Right, DE, we're just going to find Charlie Brown. Right, I've named this other menu Charlie Brown. Now this one here, I'm going to make him blue so that way I can show that that's the part that I'm cutting through. Right. Blue, Charlie Brown is my target, that's who I want to find. And these two are distracting and I need to eliminate them. Now, in this case, Charlie Brown is doing the same thing as DE. They're both going horizontally. So Charlie Brown is not a lone wolf. So what method are we going to use to eliminate them instead? We're going to use the meetup method. Okay, so to use the meetup method, we have to take moments about a location, and that location will be where our unknowns meet. So we have two unknowns. Where do they meet?
EB.
They both meet at E. So see how they both have E in their name? They all meet at E. Yeah? So what we can do here is we can say the sum of all moments. Now, you can say we're only looking at the left-hand side, and that's okay, because if we looked at the right-hand side, we'll get exactly the same forces, so everything balances. Right? The sum of the moments about E equals 0. 0 equals, okay, well, we've got DE times 0 distance, ignore it, minus CE, 0 distance. Okay, well, what else do we have? We have B, we have RB. Now in this case here, is RB, well, we have to extend this line all the way up, right? In this case here, RB, to get to our point, we're measuring from E, so we go up and around. Is it in clockwise or anti-clockwise? Okay, so we're going to write minus RB, but what is its distance? What is RB's distance?
86.
No, it's half a triangle. But it doesn't look super clear, but I'll draw it again. The distance from E to B is 1/2 of a triangle, yeah? Is that clearer now? Yep. Okay, 0.5. Okay. And then we have one other force. One other force is CE. Now, I'm assuming, right, I've told all the minions to pull, right? if it's pulling, it's in tension. So I'm going to assume that it's in tension. Yeah. Now, how far away is CE from E? How far is CE from CB from E? Charlie Brown, how far is it? 0.66. Okay, cool. Now, my assumption is that it's pulling. If it's pulling, is it going clockwise or anti-clockwise?
Clockwise.
Clockwise. So, I have to write in here, I'm going to write in blue, which means you don't need to write this. Assume tension, therefore, that way, therefore, yeah, so positive. Assume therefore clockwise, right? I made it clockwise. Okay, so what I'm going to do is, these are zeros. I'm just going to bring this one over to this side. Does that make sense? I had half a red balloon. I'm going to bring that red balloon over here. And actually, I know the value of red balloon. You know, I'm just going to write that in. Okay, so I've got 0 equals minus, what's half of 25?
12.5.
Excellent, exactly right. Minus 12.5 plus this many CEs, 0.866 CE, and then that's all we've got. If I bring this over to this side here, I can say, you know what, I'll bring this one over. I say 0.866 CE equals minus 12. Okay, those minuses both cancel out. Yeah? So that means our answer is going to be positive. And if it's positive, therefore our assumption was okay, therefore it's what? If the assumption is positive, assumption is correct, it means it was?
Intention.
Intention, exactly right. Okay, so if I was buying 86% of a Charlie Brown, right? It was Charlie Brown that was missing its leg or something, right? And if I told you that 80% of a Charlie Brown cost me $12, how much does a full Charlie Brown cost?
16.
16? Yeah, okay. Somewhere in that sort of ballpark, yeah? So I go 12.5 divided by 0.866 equals 14.3. And we said here earlier that it was in tension. Okay, we could solve, for homework I would say, can you find DE? Now in the case of DE, I'll give you a little bit of a clue for the homework. If we want to find DE, we'll have to eliminate CE, and so Chris and Charlie. Where do Chris and Charlie meet? Chris and Charlie will meet at C. Now even though C isn't part of our truss, that doesn't matter. We're just taking distances. Yeah? So we take moments about C. That's a good enough question. You know, we might just do that one. We'll do it. Yeah. Okay, so I'm going to clear this off. It's going to be a very similar process. Some of the moments about C equals 0. 0 equals. Okay, well first of all, Charlie Brown is 0. Chris Evans is 0. Right? Now, so we're finding DE. So DE is how far away from C?
0.86.
0.86, exactly right. DE equals 0.86 away. Is it going clockwise or anti-clockwise? Anti-clockwise. Okay. RB, is it going clockwise or anti-clockwise? Minus, okay. RB. Now if I've only got two things and they're the same sign, it means it's not tension. Yep. It means my assumption is going to be wrong. But anyway, so RB, which is actually 25, how far away, how many triangles is it away?
0.5.
This is C, this is B. How far away is that?
1.
One triangle away. Okay, so I'm going to write just above, I'm going to say assume tension, therefore, and where is it? Anti-clockwise. Okay. So, this cancels out, so this is going to be 0 equals minus DE equals minus 0.866 DE minus 25, right? I can then bring this side over here, right, and that's going to say 0, so now the negative gets removed. Does that make sense? Because if I bring it over here, it's now positive. 0.866 DE equals 25. So the same way that we said before, yeah. Okay, now, this is minus though. Minus 25. So that has not gone away. That means our answer is definitely going to be negative. Yeah? So we're going to say negative, therefore our assumption was, if it's not okay, what do we write? Well, so the formula, we typically engineers write NG, no good, right? Okay or NG for no good. I don't know where that came from, but I've seen that lots of people do that. Okay, so therefore it's compression. Okay. So 86 of 25, 86% of 25 means the whole amount is going to be what?
25 over 86.
Yeah, I think it's 28. 0.66. So DE equals 28.87 newtons compression. Yep, so there we go. I did your homework for you as well. Okay. Now, while I was here, I thought I'd do some. I'm going to pause some. That will do for now.